Alright everyone, I'm going to go over the last section of, or the last part of 6.3. So we're going to title this 6.3 Continued. And this section is going to be on directional angles. Now directional angles, they're going to be using the idea of the unit circle and the angles, giving us the direction of the vector. So for example, let's go ahead and start by drawing the unit circle so that we can see what we're going to be talking about. So if we draw the unit circle, we're going to have let's say this is a unit circle. It's going to be at 1, -1, -1, and 1 over here. If we have a vector that's going to be a unit vector, then it's going to be a length of 1. Our unit circle obviously has a radius of 1, so let's say that this vector u is inscribed in our circle, in our unit circle, then it's going to have a length of 1. So what we're going to be working with in this section is the idea that we can find the direction of this vector by thinking about the angle from the x-axis, the positive x-axis, to wherever the terminal point of this vector is. So this angle right here would be able to tell us the direction of this vector. And if we think about what we've been doing, this vector right here would have, if we were to construct the right triangle, then remember that this is the same thing as y, and y is given by the sine of theta. This right here is given is x, and that's given by cosine of theta. So we can also use sine of theta and cosine of theta to figure out the direction of this vector. So that's what we're going to be talking about in this section. Remember that our vector, the point of the terminal side, we use x and y. So the coordinate of this point would be x and y. Or if you remember, cosine theta, sine theta. So this is the idea that we're going to be working with today. Now what we're going to be noticing is that u is equal to, we can rewrite it as xy, the component, which is very similar to our coordinate. And we can rewrite that as cosine theta, sine theta, because cosine theta and sine theta are like our x and y. And this, we can write it as the linear combination cosine times I plus sine theta times j. So this is what we went through today in our lesson. So this is what we're going to be kind of thinking about. So whenever we want to find the direction of a vector, we're going to use the direction angle of this vector. So that's going to be given by, this is what we're going to be using. We're going to be using v, let's say some vector v. That one we're going to be able to find with the magnitude of v, cosine of theta, sine of theta. Alright, so all this is saying is that if we have a vector u and it's a unit vector and it's it has direction angle theta, if v is equal to a times I plus b times j, and it's any vector that makes an angle theta with the positive x-axis, then it's going to have the same direction as u, and we can write it this way. So we're going to pretty much use this to write vectors. So this is equal to the magnitude of v times cosine theta I plus magnitude of v times sine of theta j. Alright, and since we have, because v equals a times I plus b times j, and that is equal to the magnitude of this cosine of theta times I plus the magnitude of v times sine of theta times j, then it follows that the direction angle theta for v is determined from tangent. So if you think about it, tangent gives us both sine and cosine. So if we use a tangent of theta, we can just simplify everything into just a simpler version. So tangent of theta equals sine of theta over cosine of theta, which is equal to the magnitude of v sine of theta over the magnitude of v cosine of theta, which reduces to b over a. So b over a is, if we were to simplify, we would just be left with the numbers that we multiply times I and j. So tangent of theta equals b over a. This is, sorry about that, I need to realize that I need to keep scooting this up. This is the main idea we're going to use. Tangent of theta equals b over a. So we're going to be using this as one of our key equations. So let's go ahead and go through an example here. So let's find, there's going to be finding direction, angles of vectors. So there's going to be finding direction angles of vectors. So let's say that we want to find the direction angle of each vector. Right, and our vectors are A, which is u equals 3I plus 3j, and B, so if our vector is equal to 3I minus 4j. So if we want to find the direction angle of these vectors, we're pretty much going to be finding the angle that represents where these vectors are going. So if we look at our unit circle, whatever angle we find is going to be telling us where the vector is going. So if a vector is going this way towards the second quadrant, then we're going to be finding an angle that goes past 90 degrees. It's going to be somewhere around here. If we were to find a vector that goes this way, third quadrant, then we're going to find an angle that is somewhere past 180 degrees, and so forth. So that's what we're going to be looking for here. Alright, so we're going to use this right here, and we're going to try to find it for A. So let's look at A first. So I'm going to turn the page. So A is, we're going to use tangent of theta equals b over a. And remember that our equation is u equals 3I plus 3j. This is like our A and this is like our B. That's all this is saying, this equation. So if I were to plug those in, then I would say 3 over 3, which is equal to 1. Now I'm going to rewrite tangent of theta is equal to 1 then. So I just went ahead and simplified. Now tangent of theta equals 1. I'm going to take the inverse tangent of both sides. And inverse tangent of 1. And that's going to give me theta equals 45 degrees. So if you were to take the inverse tangent of 1 in your calculator, inverse tangent of 1 in degree mode, that gives me 45. So that's what I got here. Now 45, that would be, if you think about the unit circle, it's telling you that this vector is going to be heading in this direction. All right, so 45 degrees, that's where this vector is going to be heading, and it's a unit vector. That's what the U is for. So if you think about it, this vector has 3 and 3, so if you were to measure this side and the height, it would be 3 and 3, and that would be a vector with a 45-degree angle. So that's pretty much what we're finding here. Let's look at B now. So B, we're going to use tangent of theta equals B over A. Remember that our unit vector for B is V equals 3I minus 4J. So remember that this is our A, this is our B. So I'm going to plug them in there. So we're going to get negative 4 over 3. And negative 4 over 3 is what is equal to tangent theta. So now I'm going to say tangent of theta is equal to negative 4 over 3. I'm going to take the inverse of both sides. So inverse tangent of theta. And then over here I'm going to take the inverse tangent of negative 4 over 3. I'm going to get theta equals, now if we take the inverse tangent of negative 4 divided by 3, I get negative 0.53, negative 53.13. However, this is what we call the reference angle, and we label it like this. So a reference angle is only giving us reference to what the actual angle is. This is not the actual angle that we want to use. So our reference angle, in order to find out what the actual angle is, we need to subtract it from 360, and I'm going to tell you why. So remember that if we have a negative angle, then that means that we're going counterclockwise. So negative 53 is going to be somewhere over here. So this is your angle, negative 53.13. That means that the direction that this is actually going, because if you think about it, negative 4 over 3, negative 4 right here, this is telling us that it's going in